See, at least for the start of the stream, I'm gonna do some more for my math biology class, and we're talking about population dynamics. Spetri, holy crap! Yeah, you've reclaimed your spot as the first king. Well, you've always been the king, but you had a little streak of not like getting it, so yeah, still comfortable. You're not doubling anymore, but you know, things come and go. I hope you've been good though. Okay, this equation or this question is kind of boring. I want to speed run it. I've done this before. What we do is we're gonna divide out this thing. And then is equal to r, and then we integrate with respect to t. Actually, we can. I don't know why I'm going through this much effort to make it look nice, but been in the hamster wheel. Yeah. I feel like we use that exact saying, but I feel like there's something slightly different that's more common. Like maybe like a rat race or a rat maze or something. But yeah, for just like working. We need to do partial fractions. And that is fair enough. Work is important. Oop. 1 minus n over k. So we get 1 is equal to a minus n over k a plus bn. So n is our variable. So minus 1 over k a plus b equals 0. That's true, Boz. I need to get you to teach me English. Since it is your first language, of course. A is equals 1. Yes, okay. Which means b is equal to 1 over k. So it's 1 over n plus 1 over, I already like this, 1 over k. 1 over 1 minus n over k. dn is equal to rt plus c. I feel like your barber, did you dirty that crooked pony? Wait, the crooked pony? My barber did do me dirty because I was my barber. Oh, like the hair that's like in front, like there, it's called your bangs. But yeah, I cut my own hair for the first time last week, and I was going to try to give myself a fade. I was following along with a YouTube video, and it was just too hard to do on myself. He did it on himself, and he made it look easy, but I could not. And yeah, it's really hard to cut your own hair, as it turns out. Hey Slim, the sneaky barber got you again. He's always he is a dastardly barber. Math or what's harder, math or cutting my own hair? Okay, cutting my own hair with glasses, I think is harder than math. If I didn't wear glasses, I think it'd be a lot easier. So my mom just texted me. Oh, I have to see what it says. Oop. What is this? Sorry, she sent me a video of my nephew who's like, how old would he be now? Like eight months old or something? She's asking me if something he's doing reminds me of something. I'm not sure what. It is weird. It doesn't feel real. Like my sister being a mom is kind of crazy to think about. Hmm. Have one. If I will eventually get one, it won't feel real. Yeah, it's so weird. Okay. Anyway, Clonk. Well done is better than well said. Ooh, that's a good fortune. That's true. I think I did this integration right. You have to do a U sub. And actually, this is always positive. Is it though? Not necessarily. These fortunes, I found a random list of like 2,000 fortunes off Google, and so it just pulls a random one from that. A lot of them are really weird though, and like not very good. Yeah, I wrote all of them. Turns out when you do one of those community campaigns, people cannot donate more than 2,000 points. Really? That's stupid. That should be a setting where they'll let you adjust. Feeding a cow with roses does not get extra appreciation. What does that mean? Is that like a fart joke? Or a grass-fed beef joke? I don't know. So my campaign, Slim Flies a Kite, is not doing great. Yeah, that's unlucky that they just put that limit on you. You'll be called upon to help a friend in trouble. Ooh, that's a good fortune too. It means that if you get something special, someone doesn't appreciate it, you are wasting your time. Oh, yeah, Slim. That makes way more sense than being a fart joke. That's smart. Yeah. Okay. That I actually I kind of like that saying. Now that I get it. I take back my criticism. Um, I've done this simplification before, and I can't remember how it's supposed to work. Oh yes. Okay. Yes. Um. Hey Kyo. Hope you're doing well. Goal is to use it 3 times this week and find the weirdest times to use it. Sorry for answering your mom's text without saying and see how she reacts. I already replied though. That would be funny. Just try to slip that phrase in there and see what kind of reactions I can get. Hey Rex. Thank you, Keo. It's the old self haircut. Figured I should show off the receding hairline, you know. The troubles you have now will pass away quickly. It's another good we're on a streak of good fortunes. To steal ideas from one is plagiarism. To steal ideas from many is research. Yeah? We're the same then? um, the absolute value bars are an issue. I guess we have to do cases. Because there is a case where this thing is negative. Yes, I did add a meow sound alert. I think it was Rex's idea. Wait. I want to ignore this. I I just want to get rid of the absolute value bars. I think I'm going to do it, and if it gets me the right answer, I'm going to assume that I did it right. That like it turns out that that's okay. Because we are like I think we need absolute value bars here, but I think when I take the exponential, I can get rid of them. There we go. It's my story and I'm sticking to it. Ah, running out of room. Okay, Rex. You will be wise not to seek too much from others. That I guess so. I feel like I try not to ask too much of others, so that kind of matches me. Does this cookie only give good fortune? I mean, you are the one who opened it. This is slightly wrong, isn't it? My capital N looks like a mu. I guess so. I don't know how the fortune cookie gods work. So why don't I have a -1? Everything else is right. Causation Rex equals good fortune. Where's this -1 supposed to come from? Oh, that sounds terrible. I'm skipping the song. This song's a classic, though. Is this seriously, like, I don't think the logistic equation is supposed to look like this. You match others because he has plenty? I guess so, yeah. I'm wondering if this is, well, no, I have no clue. We could do part B and see if we get the same thing. Resolvent? What is resolvent? Am I applying the initial condition too early? Could that be the issue? That's probably it. Or I say I can do it at that stage, but I need to do a better job of it. Um, Complex analysis to the study of spectrum of operators, but Banach spaces and more general spaces. I bet this is used for something cool. I've never heard of this in my life, though. Given an A is an operator. Yes, like I think this is a little beyond me. I know a bit about complex analysis. I know nothing about the spectrum of operators on Banach spaces, though. Maybe this is a functional analysis thing. Yeah, sorry, I'm trying to like quickly see if I can figure it out now, but I don't think I have nearly enough background to understand this. I'm not sure of anyone who would know this either. Yeah, I bet that there's some cool theory behind this, but uh, I'm just very confused when I look at this, unfortunately. Sorry, I wish I could say something about it, but I don't think I can. Okay, so I think my issue with this is that C is actually n naught over 1 minus n naught over k. Okay, so that makes sense. I've seen like a simple version of that then. But that looks like a very general thing that's there. I might just want to keep it as C for now. Yeah, you're welcome to like ask a question if you have them or like hang out or whatever, but I don't think I'll be able to really say anything useful about that, so I'm sorry. CE to the RT. Oops. Okay, yeah. And 1 over c e to the minus... Ooh, whoa. What the hell am I writing? Plus 1 over k. And now's a good time to bring in our definition of c. Okay, so we can multiply this through by k over k. Get a k on top. Ooh, well, we get a k there too. So it's going to become k over n naught minus 1. Oop. E to the minus rt plus 1. And is that right? K over n naught minus 1. Okay, nice. Physics operators are not so bad. Pure math operator theory is very unfriendly. I couldn't really tell you the difference. I would definitely believe that physics would just kind of take the bits of theoretical math they like and just kind of simplify them down, though. Okay, so we have Still's equation two different ways. The second way we have to do it is by treating as a Bernoulli differential equation. These are a known type of nonlinear ODE that have a change of variables. And I think this is the substitution we want right here. Let's come down here. Need to copy down our original diffie q. Then I guess I'm going to let y equal n inverse. Is that right? Yeah. So that means dy dt is equal to minus 1 over n squared dn dt. So dy dt is equal to minus y squared? Question mark? Yeah. So then minus y to the minus 2 dy dt is equal to dn dt. So now we can plug it in right there. ry to the minus 1, 1 minus y to the minus 1 over k. Multiply this bad boy through by, I guess, minus y squared. And we get minus r y 1 minus 1 over ky. Multiply this out. We're going to get positive r over k minus ry. And this is linear. Huzzah. Okay, so integrating factor. I never heard. Paul? I need Paul. So it's gonna be mu is e to the integral p of t, I bet. Yes. So mu is e to the integral r dt. So it's just e to the rt. I'm not going to worry about the constant. Y is going to be equal to e to the minus rt, so 1 over mu, times the integral mu of t g of t plus some constant c. So e to the minus rt, I guess that's 1 over k e to the rt. I keep ugh. I'm making a square bracket there and then a parentheses there. So we end up with just 1 over k plus c over e to the minus rt. I guess we can bring in our... Ooh, I guess we can unsub. So 1 over n is 1 over k plus c over e to the minus rt. Then we flip each side. 1 over k plus c over e to the minus rt. Is this really going to be fine? It does not feel fine. It's because I double flipped. I flipped e to the minus rt without changing the sign. There we go. Okay. And then we want to figure out what c is. Plus c, just like that, right? Yeah. So 1 over n naught. I bet there's a more efficient way of doing this, but who cares? So 1 over n naught minus 1 over k. Let's get a common denominator. Is this really going to match? Yeah, it might. Guess we'll find out. Multiply 3 by k over k and cross our fingers. So we get k over n naught minus 1. Oh, wow. Look at that. Wait. K over n naught. Okay. Good. Okay. 1 second. Okay. Now the prompt did say make sure the solution makes good sense for both n less than k and for n greater than k. And like, I don't know what they really expect here. I guess we can talk about like if n is greater than k, how this thing should behave. So at time 0, if n is greater than k, this thing inside parentheses is negative. Um, what does this mean? It's between 0 and -1. This e to the minus rt is only ever going to, well, it's decaying. So we're multiplying two numbers between 0 and, well, okay. If you take like -0.5 and multiply it by say like -0.25, you're getting something even smaller and still negative. I'm trying to make some argument that the curve is going to look like this, just kind of with intuition. I know it's supposed to look like that, and that's some horizontal asymptote. I mean, it should innately make sense for both because we never had to do anything special for different cases. Well, I mean, ooh, is there a sneaky issue when y squared gets in the mix? I don't think so. Okay, I think the argument is going to be this is a negative number, or this is between 0 and -1, which means the entire denominator is between 0 and 1, which means n of t will start higher than k, or like this is going to increase k. Hey, Boston. Hope you're doing well. And then as t increases, this number is going to get closer and closer to 1, which means k is going, or which means n of t over L is going to decrease and approach k. Okay, I should type that out. If n0 greater than k, k over n0 minus 1, ugh. 0 is less than, wait, I guess 0 is greater than, -1 less than that, less than 0. So the denominator is less than, or greater than 0 and less than 1. So n of t is greater than k. As t increases, the denominator will approach 1 from below, meaning that n of t will approach k from above as expected. There we go. That's your. I'll make that a little bit cleaner when it comes time to actually LaTeX up this homework, but I think that's what they want for that question, probably, maybe. Who knows? Also, something for the other case, but who cares about that? That's a problem for future me. There we go. Good enough. Okay, problem 2. Let me grab it. I'm trying to just plow through this homework because I'm really not that interested in it. Or like, I don't know, it's just... it's stuff that I already know how to do. Find the equilibrium, plot the equilibrium as a function of the fishing mortality QE. Explain why you think n star equals 0 is or is not in equilibrium. What is the difference between Texas and yogurt? Yogurt has culture. Shots fired at Texas. It's kind of funny. It's not unfortunate at all. You're absolutely right. It's at least funny though. So it gets a pass as far as I'm concerned. And just you can make that joke like about any place. Like it's not really unique to Texas. I guess that's my one like criticism. But it's not about a place where I'm from, so I don't care. I'm just that kind of person. Um, so we factor the n out. Theoretically, we get n equals 0, but this bad boy isn't defined for n equals 0, so I think we need to throw it out. Okay. I'm gonna grab dinner. All right, enjoy. Find the equilibrium and plot the equilibria. It's a function of the fishing mortality QE. Okay. So what would in this equation, if n did equal 0, the log would be negative infinity. And that doesn't make all that much sense. So we really just need to plot that thing. QEN. So when QE equals 0, we have the point 0, comma K. Maybe we should do a different color. Then it's going to be exponential decay. And then n star equals 0, not equilibrium. Defined. I can't imagine you're allowed to have an equilibrium point at a place where you're not defined. That just seems like a non-starter. Now, what the heck is a yield curve? And what is a maximum? Well, okay, wait. Maybe part C is a hint for what a yield curve is. Maximum sustainable yield. Okay, so I don't think we called it this in class. Yeet curve? Yield. But a yeet curve would be much more fun. Okay. What is that emote? The B. Okay, I couldn't tell if it was an Among Us character or what. Okay, so... Well, is that a yield curve? Does the textbook say what a yield curve is? Okay, I just did a control F in the textbook. There is no such thing as a yield curve, I don't think. You made that. Oh, nice. Are you an artist, Vasan? Guess you want to go to page 18 or 19. You are for that emote. Fair enough. You dabble in art. Oh, hey, that's a good emote. Oh, wait, here's a yield curve, or yield effort curve. Depensation? What the hell does that even mean? What is this plot actually of? 1.5.13? What kind of... I guess it's a fucked up hyperbola? Yeah, I think so. Did we? Surely we did this at some point in class. Maybe it's not the one that I was thinking of, though. Well, this is a bifurcation diagram. Determine and plot the yield curve. Oh, you know what? Okay. Let me Google the sorry, Ali effect. That's something we did talk about in class, and I want to see if, like, this Wikipedia page mentions a yield curve. Actually, wait. This might be something slightly different. Never mind. Okay, so where does this Y star come from? Maximum sustainable yield. That's what we need for the next part. We're taking f of n star and shifting it by n star. What the hell? Okay, so f of n, this is a discrete model. The same idea should apply. Y is the amount we're harvesting. Oh. Jeez. So we're trying to maximize Y star, the amount we're harvesting. Why would the maximum of this, okay, this function, that, okay, that's fair. We didn't do any of this stuff in class. It's not like this. Oh wait, maybe we... Okay, actually I just looked at my notes. Maybe we didn't, I just wasn't paying attention. Ugh. Okay, okay, I think at least for the first part of the question, it is the yield curve is a plot of basically like trying to find where these things are equal to each other. We're gonna plot each of them individually and see where they intersect as like a graphical way of finding equilibria. Well, who the hell knows how that function looks? Desmos away. Ooh, that's a function. Okay. So this is what we're dealing with. And the point is, if I add a thing here, there's a point where A is high enough that these two only have the one intersection at the origin. Ooh. Wait. Is 0 an equilibrium point? This thing converges. I thought it was diverging to infinity. Ooh. Yeah, Vasan. Yeah, I want to take the limit of this. It makes sense now that I think about it that it would converge because logs grow slower than any polynomial, including linear functions. So just as a little test, it's a 0 from the right. Math Pond, thank you so much for the raid. I hope your stream was good. Welcome in. For anyone here on my end, please do check out Math Pond. He's an awesome dude. Fellow math streamer. Hey Gold. Hope you're doing well. I'm Math Pond as always. Please do feel free to raid and run if you want. No, we haven't been talking about Predator Prey in class. I don't think this homework assignment involves it though. No, we've been talking about like this is just population growth with harvesting. So if you have like a fish farm or something as a kink, is Predator Prey a kink? So I mean, yeah, I guess it could be. Harvesting is the prey. Oh, I guess That's true. Yeah. I mean, you know, I never actually thought about it like that, but yeah, you can actually consider this predator prey in that sense. Yeah. Hey, Baobab Tree. Yeah. And so we're doing like stability analysis and from like the next question is going to be on like bifurcations where a change in one of your parameters gives you very different behaviors for the solution to the diffie q. And so for like first order equation, there's all these different ones, which like supercritical pitchfork bifurcation sounds like a something from a sci-fi movie. It's not truly predator prey. I don't think Bob Trios. We don't usually call it that, but like, and it's kind of like based on a similar thing. It's not like a legendary. It would definitely be orange if it was in Fortnite. Yeah, I'm not a big fan of like having to memorize all these classifications. We probably don't have to like memorize them, but it'll be good to like investigate them. So yeah, I've been trying to speedrun this homework because this class, like, I really love like mathematical biology, but this class has been a little bit boring. And this question is pretty good though. It's better than I thought. Massive Attack? Oh, I don't think I've even heard of Massive Attack. Oh wait, no, I've heard this song before. I recognize it now. Is this from? Ooh, it's called Teardrop. The, it might be used in House. That really rings a bell now. It's the House intro. Okay. That means the album. Okay. Yeah, this is a good song. With the fetus singing? I don't know that joke, that reference, but um I think that's gonna be the play here, Vasen. Um oh there's a singing fetus in the House intro. I never like I've only ever seen like little bits of House. Um yeah, so for this question we're looking at this differential equation, and I think I got tricked where I was saying that n equals 0 is not an equilibrium point of this thing. Equilibrium points are what happens when you set it equal to 0, because this thing isn't defined for n equals 0, but the limit does exist. It doesn't go off to infinity, so I think it actually, we could call it an equilibrium point. And so I just wanted to like show that with a limit. 6 goes to 0 from the right. And I guess we would rewrite it like this and then do L'Hospitals. Oh, yeah, Bussin. We're on the same page. Oh, yeah, the minus sign in front is a good idea. So we'll avoid a chain rule. I like that. And we do get 0. um, don't watch if you're scared of fetuses. That might be the first time someone said that sentence. But I've got to see it. Oh, that sure is a fetus. This is the actual like music video too. Oh yeah, this is kind of creepy. You know what? I think I'm good. Who makes this for a music video? Just zooming in on a fetus. Hey Mavort, I just learned that you Americans have a different intro music for my favorite TV show, House. Really? Why would they change the song? That's kind of interesting. How tiny it's true Hamiltonian dynamics. You make a really good point. Oh wait, Singapore has their own too. Okay, so that's the American one. Is this the Singaporean one? It is, okay. This is kind of, this is a bop though. You guys also check out Mavort. He's been streaming about ODs. Before I forget. The Singaporean one, I like it. It's the European one. Huh. It's a similar song, but not the same. Was there like a rights issue, I wonder? That's interesting. So it sounds so like it sounds like the copyright free version of that song. They're from the UK. Huh. Yeah. You know what? Okay, well, let me see if Google will tell me. Why does House have a different intro in Europe? Oh, hey, screenrant.com. Yeah, the Singaporean one is kind of awesome. Licensing issues. And so Teardrop and Mass Attack is the main theme. Or is commonly known as the best. Well, that's an opinion, but okay. Okay, so this is one they wanted to use. Huh. The more you know. It's AI slop? I really? I would believe it, but I didn't really like that didn't come to mind. Could have answered him. Oh, that's fair. Yeah. I didn't even think about that. I'm just so used to websites like this being so wordy. It probably is though. Yeah, exactly. Whenever you look up a recipe, they have to have a whole story with like this is my grandma's cousin's fish's recipe. You would have to say that's fair, Mavort. Just cut out the middleman. Um, So I guess it's not to say that the slope is 0 at 0, just that I do love a good detour. I guess, well, okay, yeah, sure. The slope of n is 0 at 0. Oh, what did I, oh, go away. So I think n star equals 0 is an equilibrium. Technically, we could make a little adjustment. I'm glad to graph this thing. So like we could, I already forgot what it looks like. Alpha n l. Okay, we could like reform this equation as like like f of n minus qen. If you're really mad about n equals 0 causing issues, we could make that our new differential equation and say that f of n is equal to ln k over n for n greater than 0 and 0 for n equals 0. This is basically the same exact thing. Oh, I was about to say the song is kind of weird, but it's already over, so no point in skipping it. We plug the hole, basically. Okay, so I think we can go back to part B. So in the differential equation, we have, this is the population growth term, this is the harvesting term. We want to figure out like what's the most we can harvest without killing all our fish or whatever it is. And so we're going to plot like each part of these things individually. And look at their intersections. We're going to maximize the harvest, I guess in part C. So I'll do this function in green. It starts at the origin. And where does it hit 0 for the second time? Yeah, get hyped. I guess when ln of 1 is 0, so when n equals k. Ooh, what's the maximum of this thing? That's a helpful point to have too. This is, I almost forgot about doing the chain rule here, but you kind of need it. Ooh, it's not depending on alpha. That doesn't make any sense. Oh, well, okay, no, well, I don't know. Who cares? So these ends cancel with these ends. The K's cancel. Really? Oops. So make sure I did all these cancellations correct. I think I did. Add the 1 over, do e to the power of each side. We get k over n is equal to e. So we get n is equal to k over e. So, and actually, when n equals k over e, what is the height? This just becomes one. Ln of e is 1. Yes. Which means we get alpha k over e. Okay. This is sick. So now we get to annotate some important points on this function. Does it just trail off like that to infinity? Yes, it does. Maybe not quite that steeply, though. It's kind of lazy. A little more like that. Okay, so this maximum is the point k over e, comma, alpha k over e. This point here is k comma 0. Yes. Okay. And then the much easier function to graph is this linear function. This will be something that actually gets turned into my homework, so I want to do a decent job of graphing it. I don't need to make it that far out. Okay. So I think that's our yield curve, hopefully. I hope that's what they want for a yield curve. I'm still not completely sure, but I think this is it. Negative population. With our axes, negative population is actually like this left side over here, so we're actually okay. When we go negative here, it means the ndt is negative, so the population is decreasing. But yeah, we're good. We're Gucci. Sorry, I'm just looking at my notebook right now. Yeah, exactly. Population growth is decreasing. Okay, let's see which one makes more sense, because there's a separate thing we could do. That I'm kind of losing confidence. The thing I just drew is actually the thing that the question is asking for. There's another thing where an equilibrium point happens. Well, I guess, yeah, this is what we already solved. When it's equal to 0. Um, So either n star equals 0 or alpha ln. I already did this calculation once. Where is it? Because we did do a different thing in class, which is we made a plot that was like n star versus QE. And so n star equals 0 would be this thing right here. And then well, that's interesting. They never actually intersect. Kunal, I am exactly a Dom like a mafia. Thank you for noticing. Oh, leave the gun. Take the cannolis. Mafia? Yesterday, my neighbor was yelling at his dog while cleaning my poop. What? Why was your neighbor cleaning your poop? Your dog's poop? Or did you poop? I mean, I would respect it if Kunal was pooping on their neighbor's lawn. I'm not here to judge. Yeah, boss move. Um, I'm still trying to figure out the answer to that question, Boston. I think I actually. Okay, no. Um, I think this plot is supposed to be this plot from part A. All right, Kunal, I'm getting the feeling that you're here just to be a little troll. And I think before you escalate and say something really racy, I'm just going to cut it off here. Okay. If this isn't a yield curve, I don't know what this is. Rest in peace, Bozo. Um, Determine the maximum sustainable yield. Did we really answer B? I hope. I don't know. We weren't really making any other types of graphs, I don't think. I'm just kind of looking through my notebook right now. Okay. Can you show the question? Sure. This was for part B. Yeah, I figured out what we need to do for part C now, but... So, music's just quiet right now, or what's happening? Oh yeah, it's Pink Floyd. That's why it's quiet. So yeah, we never use the term yield curve in class, which is why I'm confused. But this is the plot that, or this is the type of plot that we were like primarily making, so. I'm gonna scroll back down in a second here. Wait, I think the professor made a typo during this part of the lecture too. Maybe I should look at the book. Maximum sustainable yield. Y is the amount we're harvesting. Now, why is this true? I think it's just a definition of Y. Yeah. How are we doing this in class? Okay. What the hell? I really don't understand what we were doing in class. Oh, maybe I do. Um, yeah. Or wait, this isn't C, this is D, right? No, it is C. So, yeah, we're, as you're right, Boston, Y does equal QEN. And we just want to plug in that point there. Right. And we found from part A that that's our point. It is fun when there's so many letters in your math that it starts like almost spell something out. Minus, oh yeah, yeah. Forgot about that alert. Floor mat 420, thanks for the follow. Okay. And so we want to maximize the harvest. Y is our harvest. So we find the maximums of things by taking the derivative with respect to QE. So like it's weird. We're like QE we're treating as a single variable. But that's okay. So we have a QE here and a QE here. So this is a product rule. Minus QEK over alpha E. Oh my god, sorry. QE over alpha equals 0. Okay. Well, we want the maximum harvest, and Y is our harvest. So at least the taking derivative equal to 0 is what we did in class. This exponential should never be negative, so we can just kind of get rid of it. But for B, it has to plot Y, right? Oh. I mean, oh. So maybe for B, they want the axes, like you're saying, to be QE and Y. That would match with what the book was doing here. So that feels right. I wish that for their axes they didn't use words and they used variable names from up here, but okay. Well, I don't know how this function looks. X eats them. Actually, I do know how this function looks. It'll be something like that. Or it's one of the functions that kind of like has a little bump and then it decays. But yeah, so I finding the maximum here is going to help plot, I guess, too. Woods RS, thanks for the follow. QE equals alpha, though? That's our critical point? Oh, that makes sense. God, the Roblox emote? Oh, that's a Twitch emote, too. Oh, yeah. Okay, by the way... Hey, on the grind, yes, I'm doing good. How about you? Why is Roblox, like... does anyone have, like, Roblox at the top of their Twitch page now? Like I noticed this like maybe like last week. It's like, why? Why is Roblox getting like a shout out? Even the front page streamer is someone playing Roblox. I don't know, man. Oh no, on the grind. It's never a disturbance. Uh, well, the only other equilibrium point was n equals 0, so we probably don't have to worry about it. Uh, so on the grind, what do you mean by reverse chain rule? Are you talking about like integration? Okay. Yeah, so like if you have something like sine of x, ooh, that's terrible x. Sine of x times cosine of x. So like I'm used to calling this like a u sub type of problem where you would notice that cosine is the derivative of sine, or you could do the other way too, but and you would take u equal to sine of x, which means du is cosine x dx. And then conveniently, this cosine cancels with that cosine. So this sine becomes a u. This cosine goes away. You just get that. So just make sure that we're on the same page with what we're talking about here. And in terms of tips, uh, unfortunately, it's a lot of practice, and you'll eventually spot the patterns. The really annoying thing with integration is that there isn't necessarily like a universal way to do it. You just need to do it enough, and it'll eventually like sink in. What I can tell you is there's this website called Paul's Online Notes that is pretty great for giving good example problems. So this is the page that will be relevant to you. And so he explains like how it works first, and then these example problems are normally really well chosen to give you good practice. They also have solutions. These are some harder ones here. And I assume they're escalating in difficulty, but I'm not sure. Or there's like different styles. There's also these practice problems and assignment problems. I think the practice problems have solutions too. Yeah, so there's a whole bunch of. I was just trying to go through some of these. Like you don't have to go too deep, but like at least like the early ones. DI method and USub. Oh yeah. No worries, on the grind. Hope this helps. This website in general is great for everything with calculus, by the way. So like he has it organized a little bit weirdly, but like early integration is in the Calc 1 tab, and then more advanced integration is in the Calc 2 tab. Okay. So we catch up with what you're saying, Boston, about a second point. Okay, yeah. And so the first thing or the part of the equation you wrote with e to the minus qe over alpha equals 0, this doesn't give you any solutions because there's no qe that makes this equation true. And that's to be expected because this function should only have one critical point. This is the point alpha, comma. This is 1. This is alpha k. Do 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 do. Okay. Yeah, so good call on that, Boston. I think what I did here is true but not helpful. And that this is what they really want for part B. Kind of going backwards. Since we're not supposed to have the maximum part B yet, but who cares? Thank you for the help there, Boston. Okay, part D. Compare and contrast your results with those for the Schaefer model, which we talked about in class. This is just logistic growth, but with harvesting. This may require careful examination of both models near the origin. Yeah, I don't know that that's significant, though. That doesn't really affect how the model behaves. I guess let me put down some stuff. So it does say specifically our results with those for the Schaefer model. So we could look at what we did for the Schaefer model for like. So Schaefer there, y of QE was QE K, it's terrible K. 1 minus QE over R, which is a parabola. I think it would be significant if it had weird behavior at the origin, but it's just 0. If it was blowing up to infinity or something, then I would think that's more important, but... Ooh, wait, for part C, they do want the actual yield. I only found the QE where that happens, but the yield is Y of alpha, which is QE alpha. No, it's not. It's alpha K. How does E drop out from this? Surely if there's a Q here, there needs to be an E there. Oh, that's an A, maybe. No? What? Oh, we're looking at just y of e. Ugh. Um, this was given to us during class. And so, like, the question is compare and contrast your results with those for the Schaefer model. Uh, and so I'm getting the equivalent things that we did in the previous parts, but for the Schaefer model that we did in class. But I'm realizing now that the way we did in class is slightly different. We're taking y as just a function of e. I mean, models near the origin. Well, near the origin, they're both going to be approximately linear. Because just like to simplify it from this, y equals x e to the minus x. This is a like near the origin. This is basically 1. So it's mostly a linear function close to the origin. In parabolas, um, at a point they're always approximately linear. Yeah, sure, syntax. I mean, I guess most things are approximately linear at a point. I don't know what I'm saying. Yeah. I want to rework this out with y QE. What is this song from? Tramp by the Stranglers. I don't know. I feel like I've heard it used in something. I'm doing this. I don't know. Ooh. I think I've done this before. It's been a minute though. I gotta remember how what the Euler totient function is. Positive integers up to a given integer n that are relatively prime to n. Right, and this is important in group theory. Numbers that aren't coprime with p. Totatives? That's a funny word. Um, yeah, I'm sure there's a bunch of proofs of this out there, but let's try and work it out for ourselves because that's Yeah, that's awesome, Fossen. Okay. Beast one said, "Take notes while I take notes." Oh, it wouldn't matter anyway because P isn't relatively prime to P, but like it'll never be counted anyway. Um. So yeah, we have P to a power. This could be induction too. Or would it be? Would it be inducting on P or on K? Maybe it's not induction. Yeah. It's like you have to do two separate inductions, like one for each of them. So maybe it's not that. Do we have other properties for phi? I'm trying to remember like what they are. Like a phi of two numbers multiplied together. I think there's a property for like phi of AB. Just the definition? Okay. This might still be a helpful property to figure out though. Because this would help us with powers potentially. Prove that later? Oh, okay. Never mind. Multiplication by P, yeah. Yeah, they have to be coprime. I did, Raven. I cut it myself, and it was my first time doing it. I did, mm-hmm. Oh, I completely missed. It says from the definition of the Euler totient function. Induction by terms of K. Uh, I mean, yeah, that's worth thinking harder about. So, the smallest case this makes sense for is P squared, right? Oh, duh. P equals 1 is the smallest case that makes sense. I thought with K equals 1, that we get a negative 1, but that is, no. Does this make sense? We're assuming phi is prime, I guess. Which you said that. Which yeah, this would not work if it wasn't prime. I don't think. I think this does make sense because the -1 needs to be there because P itself doesn't get counted, but everything else before it gets counted. Okay. So we would assume this. We want to show this. Smelling combinatorics? I don't know about that. Well, so I guess the issue with induction is we only have the definition of p to the k, so we somehow need to show that, like, it's hard to do this without properties. Well, okay. Oh, you mean combinatorics? Oh yeah, so we could start with this. Yeah. Or one to p many coprimes. Wait, I'm not sure. I'm just trying to figure out what you're saying there, but I have a thought. Is equal to p to the k plus 1 minus... Actually, wait, is this just... This could just be directly counting, and this might be what you're saying. I just haven't figured that out yet. P to the k plus 1, every single number before it is coprime, except for p squared, p cubed, ... p to the k. These are the only things that get excluded. And I guess there's k many of those? That's not what we want, though. Well, p to the 0. I think it's somewhere in a realization like this. I'm not seeing it right now. You will see success ahead. More money is in prospect. Ooh. You go, Clonk. Gotta manifest it. Damn it, syntax. It's a very good point. Never mind. We know there are p to the k minus p to the k minus 1 coprime numbers. Maybe we can transform 1 into p many coprimes. I don't know what you mean by transforming 1 into p many coprimes. I mean, we do know, like, we only have to count the number of primes between p to the k and um, p to the k plus 1. Because we know how many coprimes there are before that, right? So we only need to worry about like this range here. So the interval 1 pk, right? Okay, yeah, so I just had the... So I think we were longer to make the same realization as you. Can we take each p minus 1 numbers? Oh, you're looking for mapping. And that mapping should be p to the k. That's what you're trying to go for here. That's probably a good idea. You don't know. Like I'm just kind of looking for an excuse to take this and multiply it by p to the k. Um, but like I'm imagining what you're saying as basically naming a function that takes a number in the interval 1 p to the k and maps it to the interval p to the k plus 1 to p to the k plus 1, like that. That's not... Yes. Actually, no, that is right. Okay. And that function is going to be p to the k times whatever the input is. Hey, Sarthak? I bet there's a simpler way of doing this idea. If you have an idea for this problem, yeah, feel free to put it in chat. Hmm. The only thing I can think of right now is that, like, if we start with the right side of this, if we are sticking with the induction idea, k plus 1 minus p to the k, we factor out a p, I guess just 1p. It'd be great if we could show this is equal to phi times p to the k plus 1. We would need that identity that we were talking about before, though, that phi of ab is equal to phi of a times phi of b, or something like that. Well, these aren't coprime, to be fair, so... Actually, wait, no, I don't know what this is. I don't know. So just a number p, 2p, 3p, p minus 1p. P squared, 2p squared. Wait, could we... I think, like, this is gonna end up being a similar thing as where you're going with this, to be honest. Can we do a second induction? Can we do inductionception? Because, like, if we can show this thing is equal to phi of p to the k plus 1, that will be nice. Phi of 1, I think, I hope that's 1. Wait. BRB? Okay. I'll keep working on this. Uh p to the k minus p to the k minus 1 is derived by subtracting p to the k minus 1 multiples of p from the total p to the k integers in the range. Okay, I think we have to justify that there's p to the k minus 1 multiples of p. P to the k minus 1. Yes, Sarthak, I mean, I think that's something we, like, talked about, but I don't know how you justify that there's p to the k minus 1 multiples of p. Like, that's kind of the issue. Hmm. There's probably a way of counting it. That's what syntax error has been going for. You're back? All right. Um, I haven't made much progress. I think it's got to be what you've been saying, though, where we're taking the total p to the k integers and subtracting out the bad ones. So we need to subtract out the numbers that you're saying. P, 2p. I think maybe there would be a triangular number thing, like a Gaussian sum. Or maybe it won't be. So there's p minus 1 many of these. How many of there are these? You severely undercount? Why are you undercounting? Yeah, I think this needs to be a different number in this next stage. If it's p minus 1 again, it's going to be bad. That's... I was expecting there to be a different number, I guess. But I guess with the way this is expressed, maybe there isn't. I wonder if there's something implicitly wrong with this. I was wondering about that, but is that going to intersect with any cases here? I guess it wouldn't. Huh. Where does it stop? Um... So literally p minus 1 times p to the k? Or something like this? P to the k minus 1 times p. think that makes sense. Keeps the pattern. Yeah, because it should look like that. Okay, now, how do we count this? Oh, well, this might just be k times p, or p minus 1. Or no, this is... Yeah, we might... God, this is such a pain. Um... The next row should end earlier. No, I... it's a really good problem. I'm just being a complainer. Like, um... I think, like, this next stage with the pluses, isn't that going to be bigger? Because there's... the distance between the squares increases? Or, like, the distance between consecutive powers is going to increase? Or do you mean this is the next row? Where does this part of the pattern end? Maybe we can just start with that smaller problem. Um... Gotta be around p cubed, right? Or like this gotta be... I guess we need p squared. I guess so. Yeah, I'm not even thinking about this part yet. It should be smaller overall. Um... I don't know. This, I feel like there's got to be some like elegant way of doing this. So there are p to the k numbers that aren't co-prime with p to the k plus 1. That's what you mean. Okay. I mean, well, yeah. So, uh, I mean, I'm okay with the induction being useless. I still don't. I haven't figured out this counting thing. Like, I know it should be true. I just can't actually justify it. Hmm. I don't know. Would you be mad at me if I looked up a proof? Because I feel like there's a really nice way of doing this that it's just not coming to me. I mean, counter assumption. It's a number D that isn't coprime with P to the K. P must appear in the prime factorization of D. It's a number D that is not coprime. P must appear in the factorization of D. How does that help us? Like, we need to count the D's still, don't we? I'm not sure. Sounds good, Kyo. Thanks for hanging out. And thank you for the help with the homework questions. That says that let's count all the numbers not coprime with P to the K. Your leadership qualities be tested and proven. Ooh, okay, Skirtle. Oh, Captain, my Captain. The ship will go down with me. um. So wait. So what's inside this list? Yeah. Okay. I was about to use to answer my question before. Um. It probably even came through to you. Well, this isn't necessarily. Well, I guess it is. Number D that isn't coprime with P to the K. Something about this list just makes me uncomfortable. I feel like I don't. I feel like I don't have a grasp on what this list actually looks like still. Um, so if we're doing it like if we have 2 cubed equals 8, b of 8, we have 3, 5, 7? Is that it? And so our list is 1, 2, 4, 6. Then I guess 8 might get left off, or, well, yeah. So p is 2. P squared. 3p? Or I guess... Is this 2? I guess it's 2p. I don't know. Or is it both? They're equal here. It's probably like the key object. This probably... There'll always be a number like that. P being multiplied by all integers up till p to the k minus 1. I don't know, just having it with p's is just really messing with me, I think. Like having two, like, I guess there's like 2 variables at once with p's and k's. Pop. Can we just think it around? There will be p to the k minus 1 numbers that are not relatively prime to p to the k. Yeah, Pop. That's like the idea that we're trying to justify. It's not obvious to me, at least. I'm not much of a number theory person, though. Have we come up with a justification for why that cardinality is p to the k minus 1? I don't think we've done that piece of the puzzle yet, either. Okay, sounds good. I'm going to look up a proof then, because I want to know the good way of doing this, but thank you for the question, Syntax. I think it is. I think the property doesn't work unless it's prime. Okay, I'm going to show a proof, so if anyone wants to avoid spoilers, then stop looking. This is the proof that Wikipedia has. Showing it? Okay. So it's this right here. So P, it does have to be prime. Impossible. One or multiple of P. The greatest common denominator of P to the K in some arbitrary integer M. M is a multiple of P. Well, this is stupid. Oh, wait. No, I think I'm stupid. I didn't. I was making counting the cardinality of this set way harder than it had to be. It's literally just 1, 2, 3, 4, 5, all the way up to P to the K minus 1. But I kept getting mixed up with the different variable names. Okay, this is... Yeah, okay, this is a cleaner way of saying what was the method? I mean, the method on Wikipedia here is the exact same as what we were talking about. Just put a little cleaner. Why do they bother with... I guess they're just showing different versions of the same property. Yeah, I guess I was confused on this step. I was making this step harder than it had to be. Okay. I think I should have like gotten that one on my own, but oh well. Um oh well. Uh I guess I'm gonna go back to doing questions for my homework. I don't know. Um I don't know. The problem is that this question for my homework is kind of a pain. And so is the one after this. Um Honestly, I think I might just call it. Yeah. Yeah, let's call it because I feel like the rest of these questions are gonna be better than off stream anyway. Oh, hi, lonely me. Sorry, I was literally just about to call it. If you have something you want to talk about though, let me know. But if I don't hear something from you quickly, I'm gonna end the stream soon here. Sorry about that. What's your question? Assuming you have one. So, oh yeah, yeah. I mean, let me know because I was mostly gonna end the stream because the stuff I was going to work on is better done off stream. But if you want to ask me a question, I'll stick around to answer it. Just start calculating. You don't know shit. So like, what about adding vectors? Like, just what does it mean, or how you do it, or Yeah. Just seeing the actual question would be the best, I think. And is Millie welcome in. Uh yeah, I don't have a specific one that I can recommend, but there's a lot of lectures on YouTube that can help. Um I wouldn't use this as a primary resource, but Paul's Online Notes is a great website for practice problems, especially. Um, so like for any topic in calculus that you'll commonly see, he has a section on that. And there's a lot of really good example problems with solutions. And over here in the practice problems tab, there's even more practice problems. So this is a great place to get problems from. For an actual, like, if you want something that's more like a structured course, I bet MIT OpenCourseWare is going to have a good one. Yeah, probably along with like lectures on YouTube. Yeah, it's like you could go through here and look for something that tickles your fancy. Clonk, thank you. Yeah, I both me and the Math Niche here on Twitch, which is much more than just me, would be able to help you out with calculus questions too. If that's not enough links, let me give you one more link, which is where is it? There's this website that has free and legal textbooks, and they like university level textbooks. And so if you're looking for a book to use, that's a resource where you can grab one from. But yeah, I'll stop dropping trillions of links in chat. Let me know if you have anything else that you want to ask about. Let's look at Lonely Me's question. Okay. They give a diagram, but we can figure out what it looks like on our own. We don't need it. North, east, south, west, news. So we have north 33 east, 10 newtons. And that means this is a 33-degree angle. Then we have east 15 north at 7 newtons. So that's like that. Okay. And we have to add these two vectors together. Okay, so yeah, Pop. I don't want to stick around for too long, so I was gonna end the stream soon. But I can talk about some stuff before I end the stream if you want. So kind of the brute force way of doing this that will always work is to break these vectors up into their components. I think there's some more sneaky like geometry ways that you can do this a bit quicker, but this way that kind of I would want to show you because this way it always works no matter what. So I want to break up this blue vector into a component along the north part and a component along the east part. And conveniently, this is a right triangle. So we can use all of our favorite trig functions to figure out what these two components are. So the hypotenuse is going to be 10. And if I want to get the component along the north, I want to take cosine of the angle that we have, because that goes with adjacent. So cosine of 33 degrees is equal to adjacent. I'll just call it I guess, ADJ over hypotenuse, which is 10. So we can multiply each side by 10 to isolate the adjacent piece. And then this is a problem for the calculator. Oops, I'll get one out. Cosine 33. I'm going to call it 8.39. Well, that's not 8. And this is in newtons, but I'm going to drop off the units for now. So we have 8.39 here. And then we want the top piece now. So we're going to use sine. So sine of 33 is equal to opposite over 10. So same thing, multiply the 10 over to the other side. Plug it into your calculator. Oop. 10 sine 33 is 5.45. Nice. Now we do the same exact thing on this red vector here. So we get a component along the east, component along the north. It's a right triangle. So this time cosine of... Oh, we have to be careful here because cosine of 15 degrees is going to give us the eastern part. But this is still something we can plug into our calculator. 7 cosine 15. 6.76. And then finally we'll do sine. Plug that into the calculator, 7 sine 15. 6L67. True. 1.81. You're on the ball with the 6-7. Okay. Now we're gonna add up the components that point north. So these two. It is a magic number, yeah. And then we'll add up the numbers that point east. These are all nice where everything's pointing in the same direction. If we had a component that was like pointing west instead, we'd have to subtract it. But everything is pointing all north or all east, so we don't have to worry about subtraction here. So along the north, we're going to do 8.39 plus 1.81. Can I do this with mental math? I'm going to bet it's 10.2. Let me verify it with the calculator. $10.2, look at me go. Okay. Okay, cool. You're following along with it too. Then all the east components, so 545, 676. That one I'm not going to bother doing mentally. 12.21. And so I don't know how they want the final result, but basically what we found, north, east, we know our vector has 10.2 along the north and 12.2 along the east. So the resulting vector, they probably are going to want it in a format. Oops, sorry. I assume they're going to want it with like a magnitude and an angle again. So we can just solve this right triangle now to get our final like form for the answer. So the angle here I'll call A. We know that tangent is opposite over hypotenuse, so we can use tangent here. 12.21 over 10.2. No, Vasen. I was going to answer this question, potentially one from Pop, and then call the stream. The part D was getting kind of weird, and I was just going to do it off stream. And so yeah, for this equation here with tangent, we can take the inverse tangent of each side. So tan inverse like this, or sometimes people say arctan. Whichever one floats your boat. I prefer arctan, but... and then this is something you can plug into your calculator. So I'll do that. Arctan. 12.21, 10.2. 50.13. Okay. Yeah, or do you mean like what the answer is? Or like what I could come up with for the answer? Yeah, I should have it by the next time I stream. So if you just like remind me, I can take a screenshot of what I like come up with for that question. Yeah. I'll try to remember to do it, but if I don't, then don't be afraid to like ping me or ask me on stream. Oh, and thank you for the 11 bits. All Shores algorithm, nicely. Featuring Grovers. Okay, so just one more piece of the puzzle. We have the angle, we just need the hypotenuse. So Pythagorean theorem will give us that. A squared plus b squared is c squared. So I'm going to do square root 10.2 squared. It's 12.21 squared. More work for the calculator. $15.91. Okay. Yeah, these questions are a pain in the ass. So I say the final answer is it's a vector of 15.91 newtons, and it points north 50.13 degrees east. It's one of those annoying vector addition with directions ones, Leo. Lonely. It's like, honestly, this isn't something that you typically learn in a calculus class. This is often like a trigonometry thing or like pre-calc. If this is part of a calculus class, the good news is you're probably going to move on from it quickly and get onto the kind of like more directly calculus stuff. Oh, really? That's interesting. There are some calculus questions that are really tedious like this, but the stuff you're going to encounter early on shouldn't be this bad. Okay, yeah. So the stuff that I think of as calculus is like derivatives, limits, and integrals. So I assume you're going to get to that at some point. Um, so it's going to be like conceptually harder, I think, but they're probably not going to make you do as much work as this question is. Hey, Content Factory. Using like Sage Math or other computer algebra systems, it'd save a lot of work. Yeah. I mean, it's good to be able to do this by hand, like, at least once, but these ones are definitely just a lot of work. Okay, so, Pop, if you still want to ask your question, let me know soon. I'm going to wrap things up in a few minutes here. You get a word problem that's practical application, it's not calculus. Come on, you're not concerned about, like, grains of sand falling from a conveyor belt and falling perfectly into a cylinder? Okay, Pop. Up to you. I don't know if he's doing a Q&A, but I'm planning to read into Zach, who's a fellow math streamer too. Yeah, I think Jed is just memeing. Um, I think that'll be it for the day then. So I'm gonna cut the stream off here. Leo, anyone else who's here on YouTube, thanks for being here. Should be back on Thursday, but we'll see. Yep, it's your aura. And on Twitch, we'll look for a raid. Oh, Leo, Jed is saying my calc teachers never shared any practical applications with me. Maybe I should ask them about that. What if they're still alive? Yeah, I mean, I like calculus because it's so applied. But in your typical calculus class, they do kind of glaze over it. Yeah. Anyway, YouTube stream's getting turned off, so Leo, thanks for being here.